This is Pre-Calculus section 1.10 notes. And just in case you are confused, there is no 1.9 notes. We are skipping that section. Today we are going to be reviewing linear equations and all the interesting things about them and that we can do with them. So first we're going to talk about slope of a line. This is old school review back from Algebra 1 here. Given two ordered pairs, x1, y1 and x2, y2, slope, which we call m, is equal to y2 minus y1 over x2 minus x1. And of course I want to remind you that whichever point you determine to be point 1 and point 2 is arbitrary, but once you make your choice, you must stick with it. Horizontal lines have a zero slope because when you calculate the slope, it ends up being 0 on top and a number on the bottom. Vertical lines have an undefined slope because when you calculate the slope, you end up with a number on top and 0 on the bottom. Parallel lines have the same slope. That's what makes them parallel. Two lines that never cross have to have the same slope. And perpendicular lines, this is the one that people always have trouble remembering. Perpendicular lines have slopes that are opposite and reciprocal. So remember, with the opposite, that means that we are going to change the sign. And reciprocal means that we are going to flip the slope over. Linear equations can be written in several forms, and you use different forms depending on what your purpose is or what you're trying to accomplish. Point-slope form obviously works when you have a point and a slope. Those of you that have had me before as a teacher know the song. You got a point, you got a slope, you do the point-slope form. So your point in point-slope form is the x1, y1 ordered pair, and your slope is m. So when you're using point-slope form, you're going to be plugging values into this equation right here, and right there. Slope-intercept form looks like y equals mx plus b, where your slope is m and your y-intercept is the point 0b, the ordered pair 0b. And then standard form can look like two things. It can either look like ax plus by equals c, or some textbooks may also write it as ax plus by plus c equals 0. But either way, when you're talking about standard form, the one thing that you have to keep in mind is that A and B cannot both be 0. Because if A and B are both 0, you don't have a line. Okay, one of them can be 0. If either A is 0 or B is 0, you have a constant function. You either have a horizontal line, okay, that's the equation y equals b, and you have a line that looks like that, or the other possibility is that you can have a vertical line, and that's when you have x equals some number a, and you have a line that looks like that. So let's do some examples. It says find an equation of the line, and they're asking for slope-intercept form that satisfies the given equation. They give us the point 3,1 and the slope 4. You got a point, you got a slope, you do the point-slope form. So I'm just going to write down point-slope form. And I know that I need to plug into those three locations that we talked about. I need to plug in right here, and right here. So that's what I'm going to do. This is going to be my x1, that's going to be my y1, and that's going to be my m. So y minus 1 equals 4 parentheses x minus 3. So y minus 1 equals 4x minus 12, and then if we want slope-intercept form, we have to get that y alone, so we're going to add 1 to both sides, and we end up with y equals 4x minus, minus 11. There we go. Example number 2 just gives us 2 ordered pairs, and we have this little call-out box here. You always need to know the slope of the line to write the equation of the line. So our first job here is going to be, we have to find our slope. Our slope again is y2 minus y1 over x2 minus x1, and it doesn't matter which ordered pair you call 2, which ordered pair you call 1. So I'm going to call this one 0.2, and I'm going to call this one 0.1. So my slope is going to be negative 2 minus 2 over 5 minus 8, which gives me negative 4 over negative 3, which negative over negative makes positive. So my slope is 4/3. My second step is going to be to do point slope form, because now I have a slope, and I can pick either point. I'll pick this point, and I'm going to do point slope form. So it's going to be y minus my y value for my ordered pair, which is 2, equals my slope, 4/3, times x minus my x value, which is 8. Okay, and now I'm going to clean this up a little bit. Y minus 2 equals 4/3 x minus 4 times 8 is 32. So that's 32/3. And then if I'm going to get y alone, I have to add 2. So I get y equals 4/3 x. Now if I want to combine these together, this is a negative 32/3. If I want to add 2 to it, remember 2 would be 6/3. So negative 32 plus 6 going to be negative 26/3. You can certainly leave it like that, but if you wanted to turn it back into a mixed number, you could. So this would be the same as y equals 4/3 x minus 8 and 2/3. So either way, this is a good answer. In some ways, I like 8 and 2/3 just for graphing purposes. Okay. Our next example gives us an x-intercept and a y-intercept. Okay, so I want to call your attention to a couple of things. First of all, x-intercepts and y-intercepts are ordered pairs. So if the x-intercept is 4, then that means that's the ordered pair 4, 0. If the y-intercept is negative 7, that's the ordered pair 0, negative 7. So since you know 2 ordered pairs, you can now find your slope. y2 minus y1 over x2 minus x1. So 0 minus negative 7 over 4 minus 0. Chop, chop, gives us 7/4. So there's our slope, it's 7/4. Now we already know our y-intercept. Keep in mind that is our b value. So we can jump right to our equation now. We can say our equation is y equals 7/4 x minus 7. If you wanted to go through the rigor of point slope form, you certainly could, but you will end up with the same answer when you are done. Now let's do a little work with parallel and perpendicular. Problem number 4 says to write an equation of a line through the point 5,1 and parallel to the x-axis. Parallel to, remember, parallel to means that it has the same slope as the x-axis, right? So this is giving us information about the slope of the line. And since the x-axis is a horizontal line, Horizontal lines have a slope of m equals 0. Okay, so we can make a little picture over here. Our line is passing through the point 5, 1, and it's parallel to the x-axis. So we're trying to find the equation of that line right there. We can write down y equals mx plus b, but again, our slope is 0. Our y-intercept, though, we know is positive 1. So this just ends up being y equals 1. Horizontal line parallel to the x-axis. Example number 5 would like us to write an equation of a line through the point 5, 1 and perpendicular to the line 3x plus y equals 2. Again, this information tells us about the slope of the line, but we have to be careful here. We can't really see the slope unless we have it in y equals mx plus b form. So we have to move that 3x over to the other side. So this equation is really y equals negative 3x plus 2. So if the slope of that line is negative 3 over 1, then we are going to use the slope m equals positive 1 over 3. Remember, opposite and reciprocal. So now we've got a slope and we've got a point. This point over here is going to be our x1, y1, and we're going to do point slope form. Y minus y1 equals m parentheses x minus x1. You got a point, you got a slope, you do the point slope form. So it's going to be y minus 1 equals 1/3 parentheses x minus 5. And then we're going to distribute our slope. And we're going to add 1 to both sides. Negative 5/3 plus 3/3 is negative 2/3. Our last section here talks about applications of linear equations. These problems model a linear relationship between two quantities. Slope represents the rate of change of the two quantities in the problem, and the y-intercept is the initial value of the problem, meaning, remember when you have a y-intercept, x is 0. A dam is built to create a reservoir. The water level W in the reservoir is given by this equation, where T is the number of years since the dam was constructed and W is measured in feet. Okay, so in this problem, an ordered pair is T, comma, W, where T, and we were told this, is time in years, and W is the water level in feet. So the question is, what does the slope represent? Well, in this problem, the slope represents the rate of change of the water level with respect to time. M equals 4.5 means, that's our slope, right? Means the water level increases 4.5 feet per year. And then finally, what does the y-intercept represent in this problem? The y-intercept represents the water level at time t equals 0, which is when the dam was built. Sorry about that. Which was 28 feet.